Okay, let us go back to start our first topic, of course, in brief. Fine, we'll study best part من chapter 1 today. Okay, new share. Chapter 1. Yes, let us answer this question. Where is the mouse? The mouse disappeared. Okay. Yeah. Is that also for the American diploma? Your question regarding an American diploma is that? Rowan? Actually, Rowan, we cannot, yes, for LSAT. Actually, LSAT, we have only two main topics, which is math and English. Okay, those two subjects only. This for IGCSE, fine. And as I'm telling you, regardless what diploma you are studying, to study computer is very important. Whether the technical skill like studying the Microsoft suite or programming. No for GPA. What the meaning of no for GPA? Sorry, I didn't get you. It is like a subject in your school, for example. And you are studying American diploma LSAT, but the computer, it is offered as a subject in your school. Yes, because I taught also, and I know that they are studying programming, even in IB diploma also, as well. Okay. Okay, for one reason, my mouse disappeared. Okay, let us see why my mouse disappeared. Fine, let's come again. Here we are. Okay, yalla, let's start. Bismillah ar-Rahman ar-Rahim. Chapter 1. Chapter 1 in our course, which is data representation. And as I discussed with you before, it is regarding what the meaning of data representation. Data, we have a lot of data. We are dealing with a lot of data. El video is a data, images, sound, typing on your keyboard, letters, characters, symbols, numbering. All of those data, how it could be represented inside the computer. A computer cannot understand our human being language. Fine? So what the computer understands, that's what we are going to introduce in first chapter. What the computer understands, how the computer understands, what languages a computer can understand.
Amor.
Okay. Amor, what is Amor?
Huh?
Amor? Okay. Yalla, we have. Okay. Numbering system. What the meaning of numbering system? In math, they introduce a lot of system. We can deal with it. Decimal number system, binary number system, octal binary system, and finally hexadecimal system. In math, yes, in math. So why we are studying here? We would like to relate what they discover in math and why they are related to our computer science field. Those systems exist in math, but we used to, in our school, to learn what? To learn, we are learning what in our school? We are learning always decimal system. So let us see. This is how each chapter, this is the flow of my teaching. Just representing to you the objective of today's lesson. And this is the topic which is mentioned in the syllabus, in your syllabus, and from where you are going to study this topic. And finally, the assignment. Okay? So we have course book. So you will study this topic from page 12 to 16 and teacher notes from 1 to 10. the assignment at the end of the topic, the teacher note from 11 to 13. Okay, this is how we are going to cover all the topics during our course study. Okay? Okay. For you as a student, my advice for you as my son and daughter, for all the courses you are studying, you must print at the beginning of the academic year the syllabus to be with you for any course. When you start the class with any teacher, okay, after finishing the class, you will return back to your syllabus and check like this. Khalas, we've finished this topic today. And you will put yourself note. Did you understand the topic well? Or you need to review it again? This is my advice to my son and daughters in all courses. You have to print the syllabus at the beginning of the course, and you are going each class, you have to check, yes, we're done from this topic. Okay, okay. So here at the beginning, this is the topic regarding the syllabus. Okay, recognize the use of binary number, conversion, convert positive binary integer, and here we focus on positive because we are dealing with negative and positive number. So I'm telling my students in your syllabus, we concern only or covering only the positive binary number. How to convert binary to binary? What is the binary? It is the decimal value. We all studied 2, 3, 5, 27, 32, and so on and so on. Okay, and vice versa, how to convert from positive integer into binary. Then, what's the concept of byte and how the byte is used to measure memory? Use binary in computer register for a given application like robotics, digital instrument, generally in any control system. Okay, so this is the objective for today's lesson. Here, to represent the data, as you see, there's a lot of arrows. These arrows, why? That we are going to know about the differences between different systems and how to convert from one system to another. Fine? This is in general. But for you and for your syllabus, we are going to focus on decimal and binary system only. Of course, we are not going to study decimal numeral system, but I would like to show you that all the systems resemble each other. How? Let us see how. In everyday life, we use numbers. Number based on combination of digits. What does that mean? That if I'm going to tell you, oh, you have, how much money you have? So you're going to tell me, oh, I have 1,300,000 in the bank. Oh, it's a huge number. But all the digits in this huge number, if you will pay attention, it is compromises only from 0 and 9. From 0 and 9 digit only. Only we have 0 to 9 digit. How many? How many numbers? From 0 to 9, how many numbers? No one know? How many numbers? Okay, 10 numbers. Okay, we have 10 numbers. Between 0 and 9, we have 10 numbers only. Okay, like this, 0, 1, 2, 3, 4 until 9. If you will count, so we'll have 10 numbers. Let us say we have 10 simples in this system. We have 10 simples in the decimal number system. So we have 10, yes, we have 10. So what does that mean? That means that the decimal system is called base 10 system. It's called what? Base 10 system with radix 10. Okay, okay. Base 10 system, yes, it is called base 10 system. That's why I'm describing you system you're already familiar with. Just to tell you about this information, that the decimal system called base 10 system. Why? Because it consists of 10 simples. Position numbering system. Position numbering system. What is the position numbering system? Each numerical in a decimal number take a value that depends on its position. Depends on its position. Okay, this is called positional notation. This is called what? Positional notation. The decimal number 327, for example, it is represented like this: 320 and 7. 320 and 7. But how? All of us, yes, we studied. This is hundreds, this is tens, this is ones. Fine. So this is 100, 327. So how we can calculate this in a very simple way? We are calculating power, what is called power of 10. Position number system for the decimal systems is power of 10 system. Why power of 10? Can you tell me why power of 10? Now why? No one notice why? Can anyone notice why? No one notice, okay? Because we said that the decimal system consists of 10 simples. So we use power of 10, and we'll see now how we are going to use power of 10 to reach this 320 and 7. You see here, this is the 10, which is called the base, and here is the exponent. What this exponent represent? The exponent represents the position of the number. Represent the position of the number. Let us see. 3 to 7. The position of the 7 in the first place. We call the first place 0 position. What about the second? 2 in the second represents position number 1. What about the 3? The place of the 3 represents position number 2. So 7 has a position 0, a 2 has position 1, a 3 has position 2. So let us see how we reach 320 and 7. 7 multiplied by 10 to the power of position, which is 0, multiplied by 10 to the power of 1, 3 multiplied by 10 to the power of position, which is 2. Then we'll add them. 300 plus 20 plus 7. So we'll end up with 327. Why you are telling us this now? Why you are telling us this now? I am telling you this because we are going to move the same concept, and we are going to explain the same concept in the binary system. Okay? So you are familiar with the decimal, so you can understand it quickly. So when we are going to explain it in the binary, so you will understand it faster. Here, 4782, value multiplied by base to power exponent. You see how we are going to convert it quickly? Add the value multiplied by base to the power. What is the base here? 10, 10, 10. Why 10? Because we said we're discussing the decimal system. Okay, let's just go take binary number system, numeral system. The binary system, from its name, it consists from 2 digits. Okay, only 2 digits. Pi means 2. Only 2. A decimal, a denary means 10. Consists of 10 symbols. 0, 1, 2, 3, 4, 5 until 9. What about the binary? What about the binary? The binary consists of only 2 digits. Consists of only 2 digits. What is those digits? They are telling me 0 and 1 only. Only 2 digits, yes. But if I would like to represent 54, how am I going to represent 54? You are saying only 0 and 1. So what about the 54? we will show you how we are going to convert a 0 or 1 to represent the 54. Okay, and how to convert the 54 to be represented only using a 0 and 1. طب why 0 and 1? Why a binary system is chosen to represent the computer language? Let us say why. Because the computer is electronic devices, cannot understand anything. Only understand there is electric current or no electric current. Only yes, there is electric current, or no, there is no electric current. So it is like the lamp here. If we switch it off, so there is no light. If you turn it on, so there is a light. This on-off state represented only with two symbols, on and off. We have only two states, on and off. On and off. Okay? So those two states, they said, okay, the binary system is the best system to represent those states. So on represented by 1, while off is represented by 0. Okay? Okay. That's the reason why we choose a binary system to represent the computer language. Each digit in binary system, we name it pet. Pet. Pet means only one digit, only one digit. This digit, it could be 0 or 1, could be 0 or 1. So we are going to save here in this one digit 0, or we are going to store only 1. This is called pet. This is called pet. Only one digit, called pet. So el pet is short for what? Binary digit. Okay, el pet is short for binary digit. So the definition of the pet is the smallest unit of measuring digital data. Is the smallest unit of measuring digital data, like a centimeter, which is measuring the length. Gram, which is measuring weight. So in our digital media, we have what is called pet, like a centimeter, like a gram or kilogram. So here we have pet. El pet store either 0 or 1 only. It is called base 2 system, and I think now you know why it is called base 2 system. Why? What is the reason why it is called base 2 system?
Because we are having only 2 bits.
Yes, we have, but let me back correct. We have only 2 symbols. I think you meant this, ya Salma, because we have only 2 symbols, which is 0 or 1, not 2-bit. 2-bit means that we have 2 digits. You see, if we are going to say we have 2 bits, means that we have 2 places, 2 chairs, 2 digits. Each digit will store either 0 or 1. Either 0 or 1. Okay? So we cannot say we have 2 bits. No, wrong. We have to say it is base 2 system because it has only 2 symbols, 0 or 1 only. Okay, you got it, dear?
Yes, thank you.
Thank you. So it is represented with letter P. It is represented or denoted to as letter P. Byte. What is a byte? Byte is the fundamental unit of measuring data. Digital data. Again, yes, again, it is the same. How? Like weight. We have gram, and also we have kilogram as well, right? Both of them measuring unit for a weight. Both of them are measuring unit for a weight, correct? We have gram, we have kilogram. For a length, the measurement unit for a length is millimeter, centimeter, meter, kilometer, correct? All of them are measuring unit for a length. So same we have here for computer science. The smallest measurement unit, as we said, is a pet, which represent only 1 digit, which represent only what? 1 digit. This digit will store 0 or 1. So what about the byte? It is a group of 8 bits. The byte is a group of 8 bits. Correct? So it is the same, yes, measurement unit for digital data, but it consists of 8 bits, as we see here for the picture. 1, 2, 3, 4, 5, 6, 7, 8 bits. So the byte consists of 8 bits. And we represent it as capital P. So if we're going to say we have 2 byte, 2P, which means we have how many bits? How many bits we have? Yalla, who will tell me? If we have 2 bytes, so how many bits we have? Yes, Munir, Muhammad. Correct, Munir. Excellent. Who else? Only Munir, Salma, Yara. Excellent. Excellent. Great job. So I see we have a lot of programmers. Inshallah, we'll have in the future. So 2 bytes represent, of course, 16 bits, and it is a math, correct? 1 byte consists of 8 bits, so 2 bytes consist of 16 bits. So the term bits and bytes, both of them in computer terminology, refer to standard units of measuring digital data size and speeds, okay? And speeds. Here is 1 bit and here is byte, 1 byte. So quick question. When I'm going to ask you, and it was one of the questions in past paper in the exams, define the bit or define the byte. So the solution is, it is the smallest unit of measurement used for measuring data. I would like to highlight this, and I would like my students always saying measuring data. Don't stop and say smallest unit, or for the byte, or smallest unit for measuring, and the byte equal 8 bits. I would like you to be professional, okay? So a bit is used, or a byte is used to measure data. It's not measuring weight, not measuring length, it's measuring data. And single bit can store or can have only 0 or 1. Okay? Okay. So what about this? Oh, we have a lot of other, we have bit, we have byte, we have kilobyte, we have gigabyte, we have megabyte, we have nibble. What is the nibble? Okay, let us move kida one by one. We said only 1 digit. 1 digit named what? Yalla, 1 by 1. 1 digit named what? If we have only 1 digit. Quickly, quickly, quickly. Where is our programmer? Munir, Yara, Salma, Heba. Bit, excellent. Excellent, Riham, thank you. So only 1 bit is called, only 1 digit called bit, 1 place called bit. If we have 4 places, it is called nibble. 4 places is called nibble. But what if we have 8 places? It's called what? It's called bytes. It's called bytes, okay? More than 1 byte, we can name it word. We can name it word, okay? But we concerned actually about 1 bit, 1 digit is bit, 4 digit is nibble, and 8 digit is byte. Mostly, or the most frequent use is bit and byte. Bit and byte. Fine? We will see this only for hexadecimal. Okay? Okay. So 1 bit means that we have 2 different states. What's those states? That we have 2 values, 0 or 1. So what if your system is consist of 2 bits? As Salma said at the beginning, 2 bits means that you have 4 different states. What the meaning of 2 different states? You see, if we have 2 bits, we can store 0 and 0. This is the first possible state. Riham, for example, she will save 0 and 0. Okay, maybe Munir, he would like to save 0 and 1. Okay, so he will save in the first place 0 and the second one 1. So what about Salma? Salma would like to store in the first place 1 and the second place 0. What about Hana? She would like to store 1 and 1. Okay? What about Miss Alfred? Which one you would like to store, Miss Alfred, with us? Miss Alfred doesn't want to store anything. Fine. Okay, so let us go here again and describe to explain that if we have 2 digits, if we have 2 chairs, if we have 2 places, so it is possible to create 4 possible combination. 4 possible combination. Later, inshallah, I will show you that 0, 0 means that you have 0 decimal value. 0 and 1 mean we have 1 decimal value. 1, 0 mean we represent 2 as a decimal value. 1, 1 mean we can store 3 as a decimal values. Okay, so if we have 2 bits, we can represent 4 decimal values. It starts from 0 and with 3. 0, 1, 2, 3. So let us go back to 3 bits. Who can figure out if you have 3 bits, how many states we can, or how many combination we can have? Yalla, if we have 3 bits, who can figure out the relation? Here we have 1 bit, so we have 2 different states. 2 bits, we have 4 different states. What if we have 3 bits? Let us see together. If we have 3 bits, we have 8 different states. See? 0, 0, 0, or 0, 0, 1, or 0, 1, 0, 6, 9. Okay, we have 8 different states. I will show you how to calculate it quickly. 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is all the possible combination we can create if we have 3 places. If we have 3 digits, we can create 0, 1, 2, 3, 4, 5, 6, and 7. 8 decimal values. Using 3 digits, we can create or represent 8 decimal values. How we can find the relation quickly? If we have 1 bit, so we can write the base 2 to the power 1 bit. The exponent here is the number of digits you have. So if we have 1 digit, 2 to the power 1 equal 2. So we have 2 different combinations. If you have 2 digits, so we can write base 2 to the power the number of digits. Base 2 to the number of digits we have. So we have 4 different states. What if we have 3 digits? 2 to the power 3 equal 8. So we can represent 8 values. We have 8 different combinations. We have 8 different decimal values. So for our smart students, if we have 4 digits, how many combinations we have? How many decimal values we can represent? Yalla, our smart students. Quickly, quickly. If we have 4 digits, how many decimal places, how many decimal value we can represent? Excellent, Salma. Okay. Khalas, Salma, for sure you are programmer, right? Computer science, inshallah. Don't shock me and tell me, yes, excellent, Hannah, excellent. 2 to the power 4 and so on. Khalas, you know the trick now. So we can represent Yara, 16. Excellent. Okay. All our girls are very clever. What about Monaia? Yusuf? Huh? We would like a male voice. And I'm always saying the students, male students, clever more. Abdullah. Okay, if we can represent 16 decimal value, start from 0 and with Yes, Abdullah, and with 15. Okay, and with 15. Thank you, Abdullah. Correct. Okay, don't fill in this hole. Yani all the time, since all 16 number 1 to 16. No, wrong. It starts from 0 to 15. We have 16 numbers from 0 to 15. If you have 4 digits, so we can represent only until number 15. Until number 15. Okay? Okay. So here how we are, inshallah, after you will study, okay, you will be capable to quickly convert between the two systems. For example, here 4, how 4 could be written 100. Okay, 1 Hana, thank you. 111 mean 15. Yes, this is the maximum value could be represented using 4 digits. The maximum value is 15. Excellent. Okay, okay. Now it is time, خلاص, after we understand what the meaning of binary system, why we choose the binary system to represent the computer language. Fine, and we understand about what the meaning of bit and byte. It is time now to know how to convert from binary to denary and vice versa using positional theory. Okay? Again, binary mean base 2 system, mean that all the time I'm using any mathematical equation, my base is 2. El base is 2. Yalla, let us go. I would like just to remind you with this, which we use it before when I give you a brief about the decimal system. El value multiplied by el base to the power el exponent. El base here in the binary system is what I should write here. Huh? What should I write? I want to hear your voice quickly. In binary system, what should I write here? What is the base? Where is my programmer? Salma, Riham, Abdullah, Munir. Yes, 2, Salma, of course, Riham, right. Yes, thank you, 2. I told you. Whenever you are talking or wherever you are talking about a binary system, base equal to, like your name. My name is Riham, and binary system base equal to. Then what is the exponent? We explained this with decimal system. We said the exponent represents the position of the number. Okay, so the exponent represents the position of the number. So let us see how we will use the positional system. Okay, power 2 of 2. Just it is recap, okay? I know that you are clever in math, and you know that 2 to the power 1 is 2, 2 to the power 2, 4, 2 to the power 4, 16, 2 to the power 5, 32, okay? Here in red, I find it very beneficial because as you see, 2, 4, 5, 2, 4, 8, 6, 2, 4, 8, 6. So don't forget this, and you can write it in a very easy way. And I'm pretty sure that you are perfect. We have indices lesson for math, and you are perfect to calculate this value without calculator. So if I'm going to ask you convert the binary number, we said binary number mean only 2 symbols, 0 and 1. Okay, only 2 symbols, 0 and 1. Correct? So we would like to convert this values, which looks very scary to me. What is 11001? This could be your mobile number, by the way. I would like to convert it to denary. So let us see how. Number 1, write the binary number in power of 2. Like this. Value multiplied by the base to the power of position. So here is 1 in position 0, position 1, 2, 3, then 4. We have 5 digits. The position starts from 0 and with 4. So the value, which is 1, multiplied by the base to the power of position. You see, very simple way. Is 0, خلاص cancelled. And here multiply by 1. So I'm going to focus on this. Only the power. Only power of 2. So here is 1 plus 8 plus 16 equal 25. The exam with no calculator. It's 25. Okay? Here we are. You see, add them up. 1 multiplied by the base to the power of position. 0 multiplied by the base to the power of position. And so on. Then we are going to add them up like this. Here, I would like you to never forget that this is position 0, position 1, position 2, 3, and 4. Then add them up, we'll end with 25. Okay, we'll end with 25. So 11001 in binary system is equal to 25 in decimal system. So from now then, if you would like to use the 25, you can write 11001. If you would like to encrypt your data and you don't want your mother or father to know your telephone number or the data you would like to save, so convert it to binary. Okay? Yalla, convert the following. Let us do it together also. Here, 1001111. Quickly, I'm going to write the position here. Okay, then I'm going to multiply. I will end up with, okay, 217. Okay, we'll cancel a 0, we'll cancel a 0, and here, of course, I'm doing quickly best for this session time. Yalla, your turn. It's very simple. 1101. It's very simple for you. Okay, who will do it first? And I will give him part of chocolate. Online part of chocolate. Yalla, who will do it? Quickly. Yalla, who will compete me and finish first before me? 1011. What is the position? Quickly, 0, 1, 2, 3 position. The 0 will be cancelled. We have here what? Yalla, quickly. The value multiplied position, 2 to the power 0. Here, what we have? 2 to the power 2. And here, 2 to the power 3. Oh, you're not clever in math. You look like you're not clever in math. Quickly, 2 to the power 0 is 1. 2 to the power 2 is 4. 2 to the power 3 is 8. Right, it is my turn, so I will take the part of chocolate. So the answer is 13. Okay. Fine. The answer is 13. It is okay, or you would like me to repeat again? Please, quickly, tell me. I will give you another one. Because I will show you, if you will do this correctly, I will show you a very simpler way, but I would like you to understand first. Then I will show you the simpler way to solve it in a moment. Here, 1110. You don't want to calculate? Tell me yes or no. I'll choose one. Abdullah, can you solve it? Let us make competition between the boy and the girl. Salma, are you still with us? Yalla, Salma or Abdullah, who will do it first? But tell me, are you trying or not? So don't wait for you for nothing. Quickly, 30. Salma said 30. What about you, Abdullah? Would you confirm her answer or reject her answer? Yalla, Salma. Salma win. Salma won the game. Sarah, thank you. 30, correct. Great job. Girls, great job. Thank you. Let us go to see the correct answer. Thank you. Salma, thank you. Sarah, let us see the correct answer. Here we have. Wow, 30. Thank you. Let us go through a simpler way to do it. Okay? Using what is called weight. What is the weight? We are going to memorize this. The weight is 1, 2, 4, 8, 16, 32, 64, and 128. I think it is easy to memorize it, right? Yalla, let us say together. 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, 16 plus 16, 32. Okay, 64 and 128, etc. 128 plus 128, 256. This is called weight. This is called weight. And as I'm telling you, on computer science, there is no need to memorize. We have to understand. Okay, we have our mind. We have to understand. We'll start with 1, then start adding. 1 plus 1, 2. 2 plus 2, 4. Or 1 times 2, 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16, and so on. So what we are going to do with the weight? Yes, here we are. We are going to draw this nice table. And in the first row, we are going to write the weight. 1, 2, 4, 8, 16, 32, 64, 128. Okay, what about the second row? What we are going to write in the second row? Here we are going to write the value. Okay, so in the first row, we are going to write the weight. And in the second row, we are going to write the values. Then multiply value times the weight, value times the weight, value times the weight. Let us see example. Here, 1001. 1001, here is the value. Here is the value. And here is the weight. Then 1 multiplied by 1, 1. Here is 0, cancelled. 0, cancelled. 8 times 1, 8. Let us add them up. 1 plus 8 equal 9. 1 plus 8 equal 9. So again, what should we do? Again, yalla, we are going to draw this table. The first row, we are going to write the weight. We are going to write the weight. Thank you, Riham. Excellent. 9. We are going to write the weight. In the second row, we are going to write the values. Like here. Okay. Riham, she got it before us and she said 9. Okay. She said 9. We are going to cancel in 0 values. Okay. We have only, we are going to add the weight. 1 plus 8. Okay. So here, 1 0 0 1 1 0 1 1. Don't forget the right.
باشمهندسة الصوت راح، الصوت واطي جدا.
Since when? Because I didn't change my position. Since when is Sotra? So it is okay now? Because it is a matter of internet connection, of course. It is okay now?
Yes, yes, thank you.
Okay, thank you. So don't forget, okay, the right side position, which we name it least significance bit. We name it least significance bit. And inshallah, later in the next classes, we'll tell you why we name it least significance bit. The digit at the right side, which have the position 0, because I see a lot of students made a mistake in the exam, okay, making mistake regarding this, okay? The rightmost digit has position 0, and weight 1, okay? Don't forget this, please. Don't forget, this is some of the mistakes we saw it. Fine, a rightmost digit, okay, has position 0 and weight 1. So here we wrote the weight is a systematic word. يعني quickly you are going to draw the table and write 1, 2, 4, 8, 16, 32. It doesn't need you to think a little bit. Then I'm going to write the value in the second row. The value is here in the second row. Then quickly, the zeros will be cancelled. The zeros values will be cancelled quickly. Okay? Then let us add the weight. 1 plus 2 plus 8 plus 16 plus 128. Okay? Okay. So the answer is 155. Thank you, Riham. You are excellent. Okay. Thank you, Riham. So Riham is perfect, is excellent for math. I hope you are not using the calculator, Riham. Say yes or no. Did you use the calculator or you do it using your mind? Yalla, reply me quickly. Look like using a calculator. No, thank you, Riham. Perfect. Excellent. Okay, so it is your turn now. Do it. This is the last part in our session today. Okay, so let us do the assessment together to check if you got the point or you understand the topic or not. So kindly, it is your turn. Do it. 101011. Convert it to denary. Kindly, I would like all of you to do it, please. I would like to check and test your understanding. No, Riham, I think they envy you. Okay, try to do it again, please. Salma, I will not say the correct answer now. I would like to see all your contributions and I'm going to tell you what is the correct answer. Munir, Abdullah. Where is our male students? Are you trying to solve or not? But during the class time, of course, I will ask you to open the camera to see what are you doing. During real class time, I'm not preferring to mute your mic and I would like to hear your contribution, all of you. Okay? I want to hear your voice. No, 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 Riham. What confused you? Now let us go to see the correct answer together. Okay, here we are going to draw the table quickly. Yalla, let us do it quickly together. Who is not following, we ask, let us follow and re-explain again. Quickly, I'm going to write the weight. 1, 2, 4, 8. Yalla, I want to hear your voice. 16, 32. Okay, 64. Then here we are going to write the value 1, 1, 0, 1, 0, 1. Okay. Then we are going to cancel zeros. 32 plus 8 equal 40. 40 plus 2, 42. 42 plus 1, 43. So the correct answer is 43. Thank you, Salma. Okay, thank you, Salma. Okay. Okay. You would like to take another one or enough for today? Yes, it is enough for today, but before leaving, I would like to pay your attention to one important note. You see, if the rightmost digit is 1, so the answer must be odd number. If the rightmost digit is 0, so the answer is even number. So here, for example, we said that the answer 155, so you see odd number. The rightmost digit is 1. Here, also 43, the rightmost digit is 1. Okay? Fine. So this is the last note I would like to mention before leaving you. I hope to see you, inshallah, again and again, and wish you all the best of luck. If you have any question, and I would like you to leave your feedback. I forgot 32. Oh, okay, Riham. Thank you.
شكرا باشمهندسة سهيلة، فعلا كانت حصة مثمرة جدا، جزاك الله كل خير.
وإياكم إن شاء الله.
وأحب أقول بس للأولاد إن شاء الله أنا حطيت لكم الأرقام بتاعتنا، لو حابب يتواصل معانا وحابب يعرف تفاصيل أكتر عن كورس الباشمهندسة، تقدروا تتواصلوا معانا من خلال الأرقام دي. في انتظاركم إن شاء الله، وفي أي استفسار إحنا تحت أمركم في أي وقت. ودي الأرقام بتاعتنا. لو في حد عنده أي سؤال خاص بالكمبيوتر ساينس أو عايز يعرف أي حاجة معلومات تانية، تحت أمركم تقدروا تسألوا قبل ما نقفل. تمام، واضح إن محدش عنده أسئلة. خلاص، شكرا.
I'm so glad to be with you today. I hope it was useful, and thank you again. Allah see you.
شكرا. السلام عليكم.
السلام عليكم.
مع السلامة.
مع السلامة.
Just eat it.